So in this video, I want to talk about transmission modes and magnetic disk technology. Data transmission mode. Bytes can be conveyed from one port to another by sending the encoding signal simultaneously using the parallel data transmission or by sending them one bit at a time. That's we call a serial data transmission. So here's an example of a parallel data transmission for a printer resemble the signal protocol of a memory bus. So you can see here that a time instant and also here different signal. So we have the data, the acknowledgement, that's a busy signal and strobe signal. So basically when the um, want to send some information to the printer using parallel data transmission, the process start when a bit is placed on each of the 8 data lines here. Um, Next, the in order to the next step is that the busy line right here gonna be a check to see is that no is that in the low state or not. If that in the low state, it mean that's the just the there's no data transmission at this moment. The strobe signal right here gonna be asserted. So at this one you can see the strobe signal going down right here. And this imply that to inform the printer that there is data on the data lines. So as soon as the printer detects the strobe signal, it's going to read the data line while raising the busy signal to present right here. You're going to detect the strobe signal, raising the busy signal to prevent the host from placing more data on the data lines. So after the printer has read the data line, it lowers the busy signal right here, lower the busy signal, and assert the acknowledgement signal right here. Just the acknowledgement right here. So this one to inform the host that the data have been received. Okay, so the next cycle will perform the same. So that's basically a simplified step of the parallel data transmission from the host to the printer. So you can see that in parallel data transmission, the interface require one conductor for each of the bit. So in this design, basically parallel cables are faster than the serial cables. It means they require more line for data transmission. In compare with the parallel data interfaces, a serial or communication interface basically require fewer conductors, a less susceptible to attenuation, and also can transmit data farther and faster compared with the uh, parallel transmission. And so serial communication interface are suitable for time sensitive, which we call isochronous data such as the voice and video transmission. Right? A detail of the different mode we can find more in the textbook. So here we just give some brief information. Next one, we're gonna talk about magnetic disk technology. So magnetic disks offer large amount of durable storage that can be accessed quickly. So these drives are called a random or direct access storage devices. This is because blocks of data can be accessed according to their location on the disk. So it's not require any sequence, but it's randomly can access based on the location of the information. So this term will occur when all of the other durable storage will sequence. Okay, for example, tape that's gonna sequence when we need to access one. By one, you cannot randomly access one of the based on the location. So magnetic disk organization are shown on the following slide. Right here, this is the one of the graphical representation of the magnetic disk So we can see that these tracks are numbered from the outside edge, from 0 and increasing to the center of the disk. So this one basically the the track 0 and track 1 and track 2 and so on. Okay, and we also can see that each of the track right here consists of multiple sector right here, so where we can store the information. In between the sector we have the inter-sector gap right here that's gonna allow the disk arm to locate a different sector. So here the zoom in of the one of the sector, so we can have that the header right here used for the synchronization of the information. We have some data stored in that sector, and also we have the trailer of that sector. So basically that's the error correcting code to inform the information you read from this sector is correctly retrieved from the information stored in that sector. So between different track, we also have the inter-track gaps right here. So that's gonna be separate different track from each other. So basically, the magnetic disk gonna be a stored in different disk splitters, and that's mounted on a spindles. So here the different this splitter right here, and that's a spindle right here. Okay. In order to read or write, we have the read and write heads that are mounted on the column that swing radially to read this information. So here we have the arm, this arm right here, that's gonna move swing back in to locate different sector or different location in the disk to read or write information. So the rotating disk form a logical cylinder beneath the read and write header. So basically a data block on the disk are located or addressed by the cylinder surface in the sector. Okay, so we have the that the three parameter in order to locate a data block. There are a number of mechanical property of hard disk drive that determine how fast data can be accessed. The one of the parameters we call that seek time. That's the time that it takes for a disk arm to move into the position over the desired cylinder. The other parameter we call a rotational delay. That's the time that it takes for the desired sector to move into the position beneath the read-write head. And we have the seek time brought with the rotational delay gonna be the total access time. So we also have the transfer rate that gonna determine the rate at which data can be read from the disk. And basically we gotta compute what's the average latency of the magnetic disk. So basically it's computed by a function of the rotational speed determined by 60 seconds, that's it, per minute, divided by the disk rotation speed and time with the 1000, that's the number of a millisecond per second, and that and the total got divided by 2. So that's the way how to compute the average latency of the of a magnetic disk. Also, we have the mean time to failure, such as MTTF. So basically, this is a statistically determined value, often calculated by experiment. So it usually doesn't tell much about the actual expected life of this. However, that's gonna be desired life is usually more realistic parameter in order to determine how long the disk gonna be last or to be used to store the information. So basically, the magnetic disk technology offer a very low cost compare with the other technology we will discuss later on. But that gonna be one of the main advantage. That's a very low cost with a large storage capacity. However, the limitation include the very slow compared with the main memory. That the time we access to or to retrieve information is very slow compared with the main memory. Also, the fragility that mean easily to be broken or get crashed. And also the moving part gonna wear out, and sometimes when the disarm gonna be a have a some problem gonna get the crash to the surface of the disk. That's gonna make the magnetic disk unusable, so the information storage gonna be damaged. Reduction in the memory cost enable the widespread adoption of solid-state drives we call SSD. So basically, computer see SSD as just another disk drive, and but they store data in a non-volatile flash memory circuit instead. And flash memory is also found in the memory stick and MP3 player, as we see in many other products. So basically, SSD access time and transfer rates are typically 100 times faster compared with the magnetic disk. However, that access time is slower compared with the onboard RAM, about 100,000 order by 100,000. So that you can see that the RAM on board access time much faster compared with the disk drive. Even that's the SSD technology. And the number of gain of factor is gonna be very widely among different manufacturer and also different type interface technology we use. Okay, the detail we can found in the textbook and also through the internet. Okay, we're not going to discuss in detail right here because there's so many types, so many standard and manufacturers. So if you are very interested in one of specific technology, you can go to the that manufacturer website to see more detail. Unlike RAM, flash is a block addressable, so that's like this drive. The duty cycle flash is between 30,000 and 1 million updates to a block. The updates are spread over the entire medium over where leveling to a prolonged life of the SSD. Okay, so that's basically some basic information of the magnetic disk technology and also the SSD. Detail we can find the textbook and also the over the internet.